The most powerful telescope ever built just looked at the most ignored planet in our solar system, and what it found there has left scientists openly admitting they do not have an explanation. Uranus has been the forgotten planet for almost 40 years. The last time any spacecraft visited it was January 24th, 1986, when Voyager 2 flew past at roughly 81,000 kilometers and spent just 6 hours studying a world it would never return to. That flyby was extraordinary for its time. Voyager 2 discovered 10 new moons, 2 new rings, and confirmed that Uranus was rolling around the sun on its side, tilted at an axial angle of 97.77 degrees, more than any other planet in the solar system. It also recorded radiation levels around Uranus so extreme that scientists spent nearly 4 decades unable to explain them. And then the spacecraft moved on, and Uranus went back to being the planet no mission wanted to visit. Cold, dim, distant, and deeply strange, it sat in the outer solar system for 40 years while Mars and Jupiter and Saturn received multiple dedicated spacecraft, landers, orbiters, and observation campaigns. In the entire history of the space age, no mission has ever orbited Uranus. No probe has ever entered its atmosphere. The planet, sitting at a distance of nearly 3 billion kilometers from Earth, remains in fundamental ways, almost completely unknown. James Webb changed that, not with a spacecraft, not with a probe, but with a telescope so sensitive it can detect the faint infrared glow of molecules drifting through an atmosphere billions of kilometers away. And what it saw when it finally turned its golden mirror to wow. Already the solar system's most neglected ice giant produced peer-reviewed results that scientists described as unprecedented, unexpected, and in one specific case, impossible to explain with current models. The first thing Webb revealed about Uranus came in January 2025, when its near-infrared spectrograph instrument, known as NIRSpec, monitored the planet for nearly 1 complete rotation, roughly 17.5 hours, capturing faint, molecular emissions glowing high in the planet's upper atmosphere. The results of that observation campaign were published on February 19, 2026, in the journal Geophysical Research Letters, led by Paola Taranti of Northumbria University in the United Kingdom, and they represented the first time in history that scientists had mapped the vertical structure of Uranus's upper atmosphere in 3 dimensions. What that means in practice is that for the first time, scientists could see not just what was happening at the top of the atmosphere, but how temperature and electrically charged particles changed with altitude, layer by layer, up to 5,000 kilometers above the planet's cloud tops. That 5,000 kilometer column of atmosphere, from the clouds to the very top of the ionosphere, had never been measured this way before by any instrument anywhere. What the measurements found was immediately strange. Temperatures in the upper atmosphere peaked between 3,000 and 4,000 kilometers above the clouds. Ion densities, meaning the concentrations of electrically charged particles, peaked much lower, around 1,000 kilometers up. Both of those measurements were weaker than the models predicted they should be. Scientists had built detailed theoretical models of Uranus's upper atmosphere based on the Voyager 2 flyby data from 1986 and decades of ground-based telescope observations since. Those models predicted higher temperatures and stronger ion densities than Webb actually measured. The planet is behaving differently from what the models say it should, and now scientists have a precise, peer-reviewed measurement to prove it. But the temperature numbers were not the finding that should not be possible. The finding that stopped scientists came in 2 parts. The first was the auroras. Webb detected 2 bright bands of auroral emission close to Uranus's magnetic poles, glowing rosy red in the infrared produced by hydrogen molecules in the upper atmosphere being excited by the energy pouring in from the planet's magnetic field. Auroras are not unique to Uranus. Earth has them. Jupiter has spectacular ones. Saturn has them. But the auroras of Uranus behave in a way that no other planet's auroras do, because Uranus's magnetic field is not like any other planet's magnetic field. On Earth, the magnetic poles sit close to the geographic poles. The magnetic axis runs through the planet in roughly the same direction as the rotation axis. On Uranus, the magnetic field is tilted 60 degrees away from the rotation axis, and worse, it is not even centered on the planet. The magnetic field of Uranus is offset from the center of the planet, generating a lopsided, asymmetric, tumbling magnetic environment as the planet rotates. The auroras this field produces do not sit calmly at the poles the way Earth's do. They sweep across the surface of the planet's atmosphere in complex, shifting patterns as the tilted, off-center magnetic field rotates with the planet. Webb watched those auroras sweep and glow across nearly 1 full rotation of Uranus, and it recorded the most detailed picture ever assembled of how the planet's strange magnetic field shapes its upper atmosphere from thousands of kilometers up. The second part of the finding that should not be possible is the cooling. Webb confirmed that Uranus's upper atmosphere has been cooling continuously since at least the early 1990s. The temperature Webb measured in February 2026 was approximately 426 Kelvin, which is roughly 153 degrees Celsius, significantly lower than temperatures recorded by ground-based telescopes in previous decades, and lower still than what Voyager 2 measured during the 1986 flyby. The atmosphere of Uranus is getting colder, and it has been getting colder for 30 years or more, and scientists do not have a satisfying explanation for why. At first, that might not sound alarming. Planetary atmospheres change temperature over time. But what makes this particular cooling significant is the energy budget. Uranus is the only planet in our solar system that does not appear to radiate more heat than it receives from the sun. Every other giant planet, Jupiter, Saturn, Neptune, all of them radiate significantly more energy outward than they absorb from sunlight, indicating that they have substantial internal heat sources left over from their formation that are slowly leaking outward. Uranus shows no such excess. It appears to be in near perfect thermal balance with the sun, which already made it an anomaly. Now Webb has confirmed that its upper atmosphere is actively cooling, losing heat, drifting toward temperatures that existing models of Uranus's energy balance cannot comfortably account for. Something is happening inside or around this planet that the current theoretical framework cannot explain. Then came the moon. In February 2025, just days before the NIRSpec atmospheric observations began, Webb's near-infrared camera was pointed at Uranus for a series of 10 40-minute-long exposure images. Each exposure captured the light from Uranus, its rings, and the dozens of small inner moons orbiting close to the planet. And in those images, tucked between the orbits of two previously known moons named Ophelia and Bianca, was a pinprick of light that nobody had seen before. The discovery was announced on August 19, 2025, by a team led by Mariame El-Moudamid of the Southwest Research Institute, and it was designated S2025-U1, now officially named Uranus Dixdixate. It is the 29th known moon of Uranus. It is approximately 8 to 10 kilometers across, roughly the size of a small city. It orbits Uranus at a distance of about 57,844 kilometers from the planet's center, completing one orbit every 9 hours and 38 minutes. And Voyager 2, which flew through the Uranian system in 1986, completely missed it. Every ground-based telescope that had studied Uranus over the preceding 4 decades had missed it. Only Webb, with its infrared sensitivity and its enormous light-collecting mirror, could see something this faint, this small, this close to the overwhelming glare of the planet itself. The fact that Voyager 2 missed this moon deserves particular attention because Voyager 2 is what we have used as the foundation of our understanding of Uranus for nearly 40 years. It discovered 10 of Uranus's 27 previously known moons during its flyby. Scientists had assumed that in those 6 hours of close approach, combined with years of ground-based follow-up, we had a reasonably complete picture of the inner Uranian moon system. We did not. Webb found a moon Voyager missed. And Uranus Dixdixate is almost certainly not alone. Scientists already believe there are more undiscovered small moons orbiting in the complex inner region of the Uranian system, too faint and too small for anything but Webb to see, waiting to be found in future observations. The moon system we thought we understood is already proving to be more populous and more complex than the Voyager data led us to believe. What Webb has revealed about Uranus in just 2 years of observations amounts to a fundamental reshaping of what we know about an ice giant that science ignored for 4 decades, a cooling atmosphere that violates the energy balance models, auroras shaped by a magnetic field so asymmetric and off-center that it produces light shows unlike anything seen on any other planet, ion densities and temperatures that differ from predictions in ways that current physics cannot fully account for, a previously unknown moon orbiting between the inner rings in the shadow of Voyager's instruments, and beneath all of it, the quiet implication that the ice giants, Uranus and Neptune together, are the least understood class of planet in our solar system, and probably the most common class of planet in the galaxy. The next mission to Uranus cannot come soon enough. The Uranus Orbiter and Probe, the flagship mission ranked number 1 in the 2023 Planetary Science Decadal Survey, would send an orbiter to circle Uranus for years and drop an atmospheric probe directly into its clouds. Answers waiting there to every question Webb has raised and cannot fully answer from 1.5 million kilometers away. If the mission is approved and funded on the schedule scientists hope for, it could launch in the early 2030s and arrive at Uranus sometime in the 2040s. Until then, Webb will keep watching. And everything it finds will keep proving the same stubborn point. A planet that nobody visited for 40 years and almost nobody studied has been sitting in the outer solar system full of things we had no idea were there. The most powerful telescope ever built looked at the most ignored planet in our solar system. What it found there should have been impossible to miss, and yet for 40 years we missed all of it. There is a specific detail from the Voyager 2 flyby of 1986 that became newly significant in light of Webb's observations. When Voyager 2 passed Uranus, its energetic particle instruments recorded radiation levels around the planet that were dramatically higher than scientists expected, and higher than the current models of Uranus's magnetic field could account for. Those anomalous radiation readings puzzled scientists for 38 years. In 2024, a team of researchers finally proposed an explanation. Voyager 2 may have arrived at Uranus during an extraordinarily rare event, a period when a powerful solar wind outburst was compressing the planet's magnetosphere into an unusual configuration. Under those compressed conditions, the magnetic field would have been temporarily stretched and squeezed in ways that concentrated energetic particles far more intensely than normal. In other words, the strange radiation environment that Voyager 2 measured and that scientists spent nearly 4 decades trying to explain may have been a coincidence of timing. Voyager 2 saw Uranus on a bad day in a one-in-a-generation magnetic storm, and scientists spent 40 years building models of Uranus's normal radiation environment based on data taken during an extreme anomaly. Webb's atmospheric observations, taken during a period of ordinary solar wind activity, are helping scientists understand what Uranus looks like on a normal day for the first time. And what a normal day on Uranus looks like turns out to be strange enough without the extra complication of a solar storm. Consider what it means for our understanding of the galaxy that the most common type of planet beyond our solar system is one we barely understand. Exoplanet surveys, conducted by the Kepler Space Telescope and others, have found that planets between the size of Earth and Neptune, the so-called sub-Neptunes and mini-Neptunes, are the most abundant class of planet in the Milky Way. They appear to exist around the majority of stars that have been surveyed. Ice giants like Uranus and Neptune are the closest analogs in our own solar system to this enormous population of worlds. Everything Webb learns about how the atmosphere of Uranus works, how its magnetic field distributes energy, how its moon system formed and evolved, is directly applicable to the understanding of billions of worlds orbiting other stars. The planet that astronomers ignored for 40 years, the planet no mission ever orbited, the planet Voyager 2 visited for 6 hours and never returned to, turns out to be one of the most scientifically important objects in the solar system. And Webb, looking from 1.5 million kilometers away with infrared eyes that can trace heat and ions and molecular glow through thousands of kilometers of alien atmosphere, is finally giving us the detailed portrait of Uranus that 4 decades of neglect denied us. It should not have taken this long. But now that we are looking, what we are seeing changes everything.